This is model A. This is model A pre-calibration, जहाँ पे वो ऑफ था. Do you see this? ये आपका आर स्क्वायर. देखें आप कितना सुंदर आर स्क्वायर है ये. 98.8%. फिट देखी थी आपने उसकी. एंड देन आर स्क्वायर के ऊपर आप अगर नमक छिड़कना चाहें तो आप अपने पी वैल्यू के स्कोर्स भी देख लें. ये आपके पी वैल्यू के स्कोर्स हैं. दे आर ऑल सिग्निफिकेंट, ऑल ऑफ देम. एंड विच मॉडल इज दिस? इज मॉडल नंबर ए. ये कीमत एक्चुअल है 16,600, 16,800, 16,800, 17,000, 17,000, 17,000, 18,000, 19,000, 20,000. ये आपका ये एक्चुअल प्राइसेस हैं, राइट, बिटकॉइन की. विच डेट्स? दीज आर द डेट्स. दीज आर टिल फ्रॉम जनवरी 2 से जनवरी 13 तक. और आपकी मॉडल ए की कीमत क्या है? ये आपकी मॉडल ए की कीमत है. बहुत अच्छी फिट है ये, शानदार फिट है. एंड इट्स नॉट कि मॉडल ए कोई बहुत ज़्यादा आउटस्टैंडिंग है. मॉडल बी इज़ जस्ट इज़ बैड, सी इज़ जस्ट इज़ बैड, डी तो बिल्कुल ही आउट हो गया है. इट्स प्राइसेस हैव गॉन कम्प्लीटली बॉन्कर्स. जी इज़ कम्प्लीटली आउट, प्राइसेस कम्प्लीटली गॉन बॉन्कर्स. लेकिन अगर आप ये भी देखें ई एफ और ई एफ एंड एफ प्राइम है एक और, वो भी देख लें, वो भी नहीं चलता. सो ये 3 है ए बी एंड सी जिसमें कुछ उम्मीद लगती है आपको कि यहाँ पे आप कुछ कर सकें, बेहतर कर सकें, इम्प्रूव कर सकें. एंड विल टॉक अबाउट हाउ दैट हैपेंस. दिस इज मॉडल नंबर ए. मॉडल बी का आर स्क्वायर इज ऑल्सो ये रहा. एंड ये आपकी पी वैल्यूज़ हैं. तो इसमें 1 2 3 वैल्यूज़ तो हैं सिग्निफिकेंट, बाकी वैल्यू सिग्निफिकेंट नहीं है. लेकिन आर स्क्वायर स्टिल अबाउट 99.3%. यहाँ पे भी आर स्क्वायर देख लें 99.3%. एंड पी वैल्यूज़ भी देख लें आप, तो ये सिग्निफिकेंट 1 2 3 4 5 6 7 सिग्निफिकेंट है 6 में से. और ये मॉडल्स कौन से? रिमेंबर, दीज आर दोज ए बी सी मॉडल्स, यानी कि दीज ऑल टाई इन विद दोज इंडिविजुअल सेगमेंट्स ऑफ पीरियड दैट यू पिक्ड अप. So I want to do 2 things, right? I want to calculate the actual exact error, and I can do that easily by using this actual price as the base. So I take 16.68 minus 12.798 over this number. So 07 minus P7 over 07, put brackets in, press enter, and that gives you 0. I'm going to convert that into a percentage. And then do where are we? Percentage. There we go. So you can clearly see that this is your error term. So about 23, 27, 20, 19, 25, 19, 27, 30, 33%, right? So this is the range of error that you're seeing, and you can also see this visualized here. The orange line is model A. These are actual Bitcoin prices. This is your model predicted Bitcoin prices. So then what do? Then we do 2 things. We say, okay, let's sum this. So that gives me a sense of total error. And then there's another term that I use, and that's called sum of squares. So sum of squares you should be familiar with because you're all stats students, so you've done some level of stats before. Sum of square would simply take the error above, square it, and then sum it. So rather than taking each individual value and squaring it and then summing it, sum square will just do that for you. So that's your sum of squares. So I've got 2 values, and that's about 0.598. So convert that into a percentage. So I've got these 2 values. Now what I'm going to do is, in the class we spoke about an Excel tool called Solver. And what Solver does is, Solver basically looks at a problem, you give it a range, you give it a desired result. So my desired result now at this specific point in time is that I want these 2 values to be as low as possible. So this is my sum of error, and this is my squared sum of error. So equal. What's my desired state? My desired state, I want these 2 values to be as low as possible, and I want this to be as low as possible. That's my desired state. How am I going to get to that desired state? I'm going to get to that desired state. If you look at this model, right, if you look at this price, where is this price coming from? This price is coming from 2 areas. One is this value, so the actual value for the parameters that we're using to predict Bitcoin prices, which is USD Euro, gold, oil, unique addresses, minus revenues, the 3-month USD yield, volume traded for Bitcoin, and USD JPY. So the first element in that calculation is the value for the parameter that are being used by the model. And the second are the coefficients for those parameters as determined by our regression model in model number A. Tell solver is, why don't you change these values? Change these values. This is model A. When you change these values, create a different model. And what I want you to do is, by changing these values, I want to keep on searching for a model that reduces these values to 0. So this is my objective. These are my variables that I'm trying to change. And this is my goal, as low as possible. I'm just going to go out and set up the solver model for you. Solver you'll find under data here. Go to data analysis tab, you'll find solver here on your Excel spreadsheet. Press solver. When you press solver, this screen opens up. So now what do I want to do? I want to reduce this value, which is my sum of error, and I want to minimize it. How do I want to change it? I want to change it by changing these variables. Which variables? These variables. So I want you to change these variables, please. There we go, these variables. And then what is the condition that I want to apply? I want to apply a condition. Where is this guy? There you go. My squared sum of error, this number, is equal to 0. Now I've done 3 things. I've specified my goal. What is my goal? This is my goal. Reduce 2 to 7.9% to as low as possible by changing the coefficients of my regression model, subject to the condition that my squared sum of errors is as close to 0 as possible. And then I press solve. You can see that there is something happening here. It says objective cell. So this is what Excel is doing. It's changing the values and trying to calculate the value of this cell over here. And as it does that, it's going to we hope it'll get as close to a solution that works. And if it can't find a solution, it'll come back and say, I'm sorry, I couldn't find it. My apologies. This is the best that I can do. And the best that it can do is the result you want to look at. And I hope our expectations by doing this, we'll possibly get to a slightly better fit of the model. So solver could not find a solution, which is okay. We're perfectly fine with that. We say, keep the solver solution. I don't mind, but I want to see how far could you possibly get? Where could you possibly get to? And you say, okay. And then we find out if our result, there we go. Do you see the difference? So what was 27, 30, 40, 27, 30, 40%? All of this is now down to a more manageable level. Your sum of error is now down from 270% to 1.2%. Your squared sum of error is down from 60% to about 1%. Look in terms of your fit. Look at the fit. There's your fit. You've calibrated the model. So Excel gave you a model. You use that model to get starting point, and that starting point had a horrible fit. And then what you've done is you've gone out and said, okay, this fit doesn't work. I think you have the right idea, but your parameters are off. So let's play with the parameter to see if we can get to a better fit. And then you think in terms of what are the parameters that Excel has emphasized in this calculation. Let's take a look at those. So unique address, Excel's cancelled out. It says, there is no intelligence here. USD JPY, Excel's cancelled out. No intelligence here. USD Euro, Excel's cancelled out. No intelligence here as far as Excel's concerned. But it's kept gold, it's kept oil, it's kept minus revenue, it's kept the 3-month bond yield, and it's kept volume. So it's reduced of the parameters that you had, which was 1, 2, 3, 4, 5, 6, 7, and 8. You had 8 parameters here. Of the 8 parameters you had, Excel said, I don't want 3, I'll just take 5. So it's already also reduced your model to maybe a more manageable set. And then you can repeat this exercise for all 4 models to see, is there a version of the model that would possibly fit?